Thank you very much. Good morning, everybody. It's my first time here, so I'm discovering the place, wonderful one. So many thanks to Finding Petroleum and to David for giving me the opportunity to present today. It's a pleasure. So we were discussing about how we can manage the declining field with geophysics. Thanks to the previous presentation, I'm sure you all understood that geophysical monitoring solution can help you to manage declining field, whether it is semi-permanent or optical one with permanent system. I fully agree with what Carl just said to say that optical permanent system can be a good solution for offshore PRM. So, having said that, let me introduce myself. So my name is Habib Alkhatib. I'm working in CGG Veritas for almost 8 years now. I started as a reservoir geophysicist with a master's degree in geology. Then I moved to the sales and marketing before joining 2 years ago the geomarket and global marketing division of CGG Veritas and be in charge of some business development within CGG Veritas. And recently I took the position of business developer manager for permanent reservoir monitoring onshore and offshore within CGG Veritas. And today I will discuss and present you the solution of permanent reservoir monitoring onshore and offshore and the associated challenges and opportunities. So before starting, and especially because Chris before just mentioned that you can have semi-permanent system, I would like to start with a definition about what is permanent reservoir monitoring system for CGG Veritas. So this is a definition that is applying for CGG Veritas and for this presentation. Basically, if the boundaries of reservoir monitoring are well understood, what is seismic permanent reservoir monitoring is not. So basically, we consider that it is equipment permanently installed, whether it is sensor or sensor and source. It is allowing you to do continuous monitoring, and this is a key part of permanent system for us. And you can achieve the highest seismic repeatability, whether it is active or passive. In addition to that, you have also the idea of long-term monitoring, like Carl just mentioned. And it is typically for 10 to 25 years offshore, which is in fact what you have to do with optical from our point of view. Onshore, optical is not maybe the right one because you can access your sensor and repair it in case of a failure. But it brings you with a closer relationship and interaction between contractor and client, and this is quite new. And indeed, it is not exploration-oriented. PRM are reservoir-oriented. So if you agree with this definition, no matter who is your provider or no matter what is your solution, PRM solution will have to face the same challenges and to embrace the same opportunities. And that's what I will try to show you now. From a CGG Veritas point of view, we consider we have two permanent reservoir monitoring solutions as of today, which are the onshore Seismic solution, where receiver and sensor are permanently buried, and the offshore OptoWave system, an optical system. There's a lot of other candidates and potential candidates. Chris just mentioned nodes. One day nodes may be permanent, and it will fall under permanent reservoir monitoring for us. So the overview of the presentation will be quite simple. We'll start with the challenge of permanent reservoir monitoring and try to understand why we still need to do some business development with PRM. Then I will present the existing PRM solution, giving you two examples with data of our integrated Ekofisk and Schoonebeek experience. Sorry for my Dutch pronunciation for the Schoonebeek. And then we will finish by providing you some insight about what can be the opportunity of PRM. So the challenges of PRM. It all starts with the challenges for our industry, and we started discussing today about that. Rob said we need to cover the gap between the estimated increase in demand and the declining of production. He also stated that you need to push as much as possible the recovering factor upper 32%, which is the average worldwide recovery factor. And instead of drilling more and more, you need to drill intelligent and to be smart so that you can maximize your oil and gas assets. In the previous presentation, you saw also that the 4D seismic already demonstrated benefits in order to push and help this EOR. So people start thinking, if 4D seismic allowing you to have a better understanding of your field, how can you increase the signal-to-noise ratio, the 4D signal, and go beyond in 4D imaging? And people say, if we don't move the receiver and even the source, then we will increase this 4D repeatability. And that's where we came with PRM. So PRM, in a way, was designed for managing declining oil field, and that's why I'm presenting you that today, by reaching the highest seismic repeatability. So Chris showed you some of these curves. What is the challenge for PRM? Why PRM is not installed everywhere in the world like we expected 10 years ago? It's mostly because of the cost. Yes, PRM is expensive. Is PRM too expensive? That is the right question. Is PRM less expensive than a conventional solution? No, definitely. And it will never be. So people in our industry are showing this kind of curves to say that over the life of field, depending on the number of acquisition, the cost, cumulative cost of a permanent system is becoming lower after 10, you can put it 5, you can put it 2, depending on the field, than a non-permanent system. But the problem is the costs are loaded up front. So there is also another weakness in such a graph, is that with a non-permanent system, over the lifetime of a field, you will never do 20 acquisition. The maximum you will do is 6, 7. So if you apply only 7 acquisition to a conventional solution, then your 2 curve will never cross. And the PRM system will always be more expensive. So it is surprising for somebody like me who is expecting to promote and business develop PRM to say that it is more expensive than a non-conventional, a non-permanent system. Yes, it's true. But I believe that we should not focus on the cost. What you look at here is more like an asset of your field, like a well, for instance. You load your cost upfront, and then you try to recover the value. So let's focus on the value instead of the cost, and see if a PRM system can be valuable for you. PRM is all about not just 4D imaging, but bringing more and more images so that you can have a movie instead of just a series of images. So talking about a movie, how can we make a profitable movie of the underground? I was in the CGG 2 weeks ago, and coming back from the CGG, I fly over to Los Angeles, and I see the Hollywood Hill, and I say, okay, is it possible to do a real movie, profitable movie in Hollywood? So how to make a profitable movie on Hollywood? So first, you need to have a good scenario. You all agree with that. Then there is an initial investment for sure. And if you came with a famous actor, Sigourney Weaver, for instance, and a great film director such as James Cameron, then you can tell a story. And if you have a budget and you're ready to invest $237 million, that's a lot, even for the oil and gas industry. Then you can create a movie, a profitable one, such as Avatar. And Avatar is a profitable movie. Can you guess how much revenue Avatar earns? 2 times, 5 times more? No, more than 10 times. The total estimated revenue is $2,782,000,000. So that's more than 10 times. So yes, you can do a profitable movie. So now, can you do a profitable movie of the subsurface? That's the point. So you still need to have a good scenario, and Carl started to mention that. It is all about what I call the PRM engineering and feasibility study. Yes, a PRM system, you load your cost upfront, and after the operational cost versus the capital cost is low, 6%. So you need to value your asset as much as possible. But there are limiting factors to find the optimum repeatability. The 4D geophysical response of the subsurface, and also the turnaround. There is no point about providing an acquisition each 3 years, each 3 weeks, if you don't have time to analyze the data. In order to mitigate those two limiting factors, we believe in CGG Veritas that integration, close collaboration with clients, and R&D can help us to increase this 4D signal-to-noise ratio and decrease the turnaround time. You also need an initial investment. These figures came from the Ekofisk. It is not the real figures, it is what you can find on the internet. We assume the Ekofisk permanent reservoir monitoring system to cost 100 million, more than 2 times less than Avatar. So if you are ready to put this initial investment, then you need to find some knowledgeable actors. TGS is one of them. CGG Veritas is another one. You have, for instance, the Seismic solution, the Octowave solution, and you need to find a great film director because you need to integrate all the different components from equipment, acquisition, and processing. It could be a client, it could be a company, a contractor. It could be CGG Veritas. But the story you need to tell is where the oil is going. And if you do so, how much oil, extra oil you need to extract on Ekofisk in order to achieve the same value than Avatar. So I make a rough computation. It is a basic one. The Avatar was 2,782 million. So that means with an average price of $100 a barrel, you need to increase your production from 27 million barrels, which means a small increase of 0.8% of the estimated today production, not the reserve, the estimated production of Ekofisk. So I believe that with these figures, yes, you can do a profitable movie of the subsurface. So having said that, I will move toward the solutions. So what are the solutions? So before talking about a solution of CGG Veritas, let's see what are the field of expertise? Because providing a solution is all about knowing, are you capable of providing an integrated solution? So a PRM project, it's like a 4D project. You're all familiar with those curves. You start with the feasibility study, the survey design and engineering, pre-project planning management, PRM seismic equipment. You install it, you do the shooting, several one, you do the processing, and then you do the 4D data interpretation and integration. So if we map this with the division of today's CGG Veritas, then you see that we are present almost everywhere, from the feasibility down to the 4D seismic processing and even a reservoir. The two missing points are the PRM installation. This is not our core business. However, I believe that we should be more tight with some installation company because this is a bottleneck in terms of cost of PRM system, and also for the interpretation and data integration. But this is typically the boundary between a geophysical contractor company and a client. So how to make bridge between this and this in order to reduce the turnaround is also a challenge for a PRM. When I'm showing you this, I'm showing you that this is all about 4D imaging. But is PRM all about 4D imaging? To decide to go for a PRM project, yes, you need to think about the 4D. But once you install your PRM system, you can use it for more than 4D and go beyond 4D in order to extend the value of PRM system, such as microseismic, reservoir study, risk surveillance, and a lot more. I will come back to that, but I would like to tease somehow, to make you a teasing of what could be the opportunity of a PRM system. It's like when you are doing a movie, then you can sell some t-shirts, then you can sell some video games. There is extra than just a movie. Moving back to one example, the offshore example of Ekofisk. Ekofisk is a very well-known field, mentioned several times today. So we have installed a PRM system on Ekofisk. So you know it's a fractured chalk with a high porosity but low permeability. There is a surface obscured area of 1/3 that is covering the central part of the field due to a gas cloth. And the client was not looking for the time shift because the time shift are very easy to catch on Ekofisk. They were looking for the 4D amplitude subtle changes on Ekofisk in order to characterize their production effect, which leads them to think that they need a very highly repeatable 4D solutions. And that is why ConocoPhillips and their partners, PLO 18, went to install a permanent system on Ekofisk. And CGG Veritas get the chance to have an integrated solution made of 4 important parts. The first one is the equipment. We provided the OptoWave optical system. As of today, we installed 400 stations, and none of them had a failure so far. Just to go in the way of Carl saying that, yes, optical systems are reliable. We have a dedicated source. That's point number 2. We're using our advanced 4D processing, and we tune it for PRM, because PRM is not just a classical 4D. We have a better understanding of the field. We can iterate our processing sequence in order to deliver a better result for our client. And the last point, which is maybe the most important one now, is the experience. We have now 2.5 years of experience on Ekofisk, implementing such a pioneer technology. We just finished the 4th survey in June, July 2012. Having said that, you had been in touch with some NRMS value from the beginning of the day, and I'm going to show you some NRMS maps. Those are the difference between the first and the second acquisition, first and 3, 1, 4, 2, 3, 2, 4, 3, 4. There is about 6 months time period between one survey and the next one. What you could see here is that on the center part, there is a production effect associated with the surface obscured area. So if we want to check the repeatability of the system and to demonstrate that PRM systems are very repeatable, then we need to remove the central area where the production is going. And if we do so, then we can compute this kind of statistic. And as you can see here, on one loss on one survey and over the other one, we can reach a very low NRMS ratio of 3.5%, which is way beyond the 6% you seen earlier. This is all thanks to a PRM system. To give you a better understanding, compare this to a classical towed streamer offshore North Sea, you have classical value range between 10% and 20% for the worst. So PRM systems are really highly repeatable. Then I'm going to show you some seismic. This is a seismic compared the first acquisition and the third. Be careful, the scale is up by 2, otherwise you will not see any difference. That's the point of the repeatability. And here you see the time shift effect mainly. And when you correct from the time shift in order to see if you are able to catch some of the subtle amplitude shift, then still you see the amplitude shift on Ekofisk. The last part on Ekofisk is about the capitalization of experience. Having a huge extensive experience on Ekofisk, allowing us to decrease the turnaround between the shooting. We started for 40 actual shooting days, get rid of the weather downtime, up to 29, reduced by 10 days. On the processing, it's even better. We were, for the first one, completely out of the expected turnaround, but for the last one, the expected turnaround was 45 days after the last shot of acquisition, and we were able to provide our client with results 24 days after the last shot, less than 1 month. That means client has 5 months to integrate and interpret the results. This is all about reducing turnaround through integrated team and experience. So now, another example, onshore. We are implementing a seismic solution, the onshore PRM solution, east of the Netherlands, close to the German boundary, in the Schoonebeek area. This was an old field discovered in the 46 that produced until 96. Production stopped, but recently Shell and NAM, the operator, redeveloped the field by putting 44 production wells and 25 injector wells. Basically, those are horizontal drilling, where you have the injector on the center and the producer on the side. The expected recovery is huge. And they had a problem. On some of the pad, the production was not as per the expectations. So they challenged CGG Veritas and asked, are you able, it is a steam-assisted gravity production. So they told CGG Veritas, are you able to monitor the steam front injection? And we implement Seismic in order to see if we are able to do so. So what is Seismic? Seismic in a movie. So short. The Seismic system is a system where you buried under the weathering zone your source, simultaneous buoyant source, and your sensors. During the lifetime of the field, your sources are continuously emitting. So you record continuously. And therefore, you are able to catch the 4D response from reservoir day by day and providing the client with an image day by day. Therefore, when the client is starting the steam injection, you think, you believe, you hope that you will be able to see the steam front injection chamber. If you're able to see the steam front injection chamber moving on a day-by-day basis, then you can assist the client to take the right decision, whether to increase the injection, to stop the injection, or to optimize some drilling. Moreover, having the sensor permanently buried gets you rid of the near surface variation and also is decreasing the environmental impact of such a system. Especially on Schoonebeek, there is some potato field over there that are still harvesting during the end of the summer. So, having said that, a picture of the Ekofisk field, we implement our solution only on one pad. That means one injector and two producers. It's made of 5 receiver line and 3 source line, like you can see on this draw. And we were able to provide a day by day. So this is a day by day. You have the steam injection over there. So after 138 days, stop the injection. So you are expecting to see no more variation, big variation in time shift and amplitude. That's what you see. So this is the first good news. The second good news is you see that the first effect you can see are some amplitude variation, which are believed to be mainly driven by the pressure. So when you start injecting, the pressure in the field is increasing and the amplitude variation are coming. And then, depending on the steam front injection, temperature of the rocks are changing. Therefore, you can have some time shift. So those are the results. What you can see here is that if you believe that you can trust this, then the steam front injection is not moving homogeneously. And you can see that it's reaching this producer, but never reach this producer. It has been confirmed unfortunately, by the production rate. This one didn't produce. Another thing is, as you can see here, there is 2 green parts that are in fact observation logs. And on the arrow here, they never seen steam front injection. And that had been confirmed by our results, where we never saw some steam front injection. So those were really encouraging results, and the client was really satisfactory. But we are willing to go further and model in 3D where the steam front injection is going. And do like they are doing now in Hollywood, doing some 3D movie instead of just 2D or time-lapse. And if we are doing that, then we can monitor the steam front injection and try to explain with the client why those observation labs never see the steam front injection, why this one is a good producer and this one will never be a good one. And by a matter of fact, here, there is a fault. And the client was not knowing if the fault was permeable or non-permeable. And this Seismic PRM system provide the client with the results and an answer to that. So, as a conclusion, we need to discuss about the opportunities of a PRM system. So, PRM are field of experiment, as they installed for a long time. And there is new challenges that are coming. We need to carry out the high resolution sensor up to the reservoir and the overburden characterization, not just simple wiggles for the imaging. We need to reduce the turnaround and the price through integration, maybe also with the installation company. And this is applicable not only to CGG Veritas, but we believe it is applicable to the whole industry. We need to master the sensor source coupling in the underground, especially for hydrophone. When you trench a hydrophone, you need to clearly understand what the coupling will be. You need to enhance the source repeatability. Because if for a streamer survey, the source repeatability is not as important as the streamer repeatability, when your sensors are not moving, then your source repeatability is becoming more and more important. And we are working with ConocoPhillips to develop a better source repeatability offshore. For the data and knowledge, and this is important, are important. Because when you think about a project that will last for 15 to 20 years, you are not expecting the same geophysicist to process this for 10 to 15 to 20 years. He will be mad. Then you need to take into account and to embrace new opportunities and go beyond just 4D imaging. I mentioned risk surveillance, microseismic. We need to work about integrating the geomechanical effect on field, noise and fracture monitoring, seismic well drilling, link with permanent downhole monitoring solutions. This is a very interesting area. As a conclusion, I think it is a new age for our industry PRM. Feasibility and integration are critical to leverage the PRM value. A complete on- and offshore offering are helping the industry to enhance PRM solutions like CGG Veritas did on Schoonebeek and Ekofisk, using them not only to provide good results to clients, but as field of experiment to push further the use and the value of such a system. I showed you two integrated industrial successful solutions where multidisciplinary coordination together with clients were key. And synergies between the two does exist. A field, an oil field, doesn't care if there's 1,000 meters of water top or just no water at all. It will behave same. So in a way, onshore and offshore PRM system had a lot of synergies. And we are lucky in CGG Veritas to be on the two system. And last but not least, there is a lot of new R&D opportunities. Those are very challenging, and I believe that today, unfortunately, a PRM system is not delivering its full potential. I would like to thank you for your attention, and a special thanks also to Shell and Name and the PLO 18 license partner of Ekofisk for giving me the right to present you some of the images today. Thank you very much.
Any questions? Yeah, please, Chris.
Very nice talk. Enjoyed it. On the seismically obscured area for Ekofisk, have you looked at the converted wave at all? You've got a 4-component sensor there.
Yes, we performed a project on that. The results are very encouraging, and most probably you will, if you attend the next EAGE, there will be a paper on that.
All right, thank you.
The onshore, the onshore sensors, that wasn't fiber optics, was it?
No.
Do you see fiber optics just, as you were saying, that there are many similarities that you could argue about between onshore and offshore. Do you see fiber optics sort of taking over onshore as well? I mean, as a possibility?
That's a very interesting question, and the answer is not very clear, unfortunately. Why we went for fiber optic offshore, it's mainly because the cost to repair a system when it breaks is way too high compared to to implementing fiber optic. Today, a fiber optic system costs more than a non-fiber optic system. And onshore, it is really easy to take a machine, dig it up, and just repair the cable in case of a failure. So that's why, plus the environment is less challenging onshore than offshore. So if, and that's the trend, fiber optic technology are becoming cheaper and cheaper, then it will be interesting. So I believe, yes, in the future, but not for today.
All right, yeah, please, Steve.
Thank you. Stephen Ferris with PGS. Could I just put a little extra onto that? PGS and Shell are working together to develop a million-channel land system, which is based on the same fibre optic technology, the geophone technology that we're using in our permanent monitoring system. So it is happening. Yeah. It's being tested.
Yeah, yeah.
And they'll be looking at it.
That's the future, I guess.
A million channels. That's quite a lot of channels.
But for the moment, there is not the cost for implementing a million permanent reservoir monitoring system channels is not yet accessible for. We can do a profitable movie. Yes, exactly.
Thank you. A question. So far, the Seismovie, correct me if I'm wrong, but it's only been used for fairly shallow projects, gas storage and steam-assisted gravity, shallow oil, for example, in Canada. Maybe a couple of dozen projects around the world. So how do we get this into use for more conventional deep reservoirs?
Yeah. So thanks for the question. Indeed, CGG Veritas is working in order to develop and target deeper reservoir, and we are working especially in Middle East to answer this. So that is referring to my comment regarding the coupling of the source and the coupling of the sensor. We are working into a more powerful source, continuous source. That's one way. The other way is to bury deeper the source, more closer to the reservoir. And we are also thinking about enhancing the coupling between the underground and the source. So that the three main areas where we need to have other pilots with pioneer companies such as, I hope, some Middle East company or other company in order to push those ideas further. So we have already some projects ongoing on that.